Welcome to my presentation. In this presentation, we shall see how to use the multiplication property to solve equations in one variable. And we are looking at equations of this type. Ax is equal to b. So the multiplication property is telling us, let me write that here. Multiplication property. I will explain what this I will state what this property is, and we will use this property to solve some simple examples. The property is stating that for all real numbers a, b and c, c not equal to 0, a is equal to b if and only if a times c is equal to b times c. So the number we are introducing here is we're going to introduce a value which is c on both sides, and this time we are going to multiply that on either side of the equation so that we do not create an imbalance in the equation, but at the same time want to solve for the variable in that equation. So that is the property. So if the property is a bit confusing, it will be explained a little bit more in the example which is going to follow. Okay, let us take an example. Let me explain this multiplication rule with a simple example. Let's say we want to solve this equation, 3x is equal to 6, right? So how do we do this? Let us use the multiplication property to solve this example. In here we have, on the left hand side, we have 3 times x. 3 will multiply to x, 3 times x. We want to find the value of x. We want to isolate the x value. So therefore, what do? We want to multiply by a number which is by the reciprocal of the value 3. If we have the number 3, the reciprocal of 3 is 1 over 3, and one of the reciprocal properties is telling us that if you take the value and then multiply by its reciprocal, the value is always going to be equal to 1, and therefore in this case we're going to say we're going to multiply by 3 or multiply by 1 over 3 on both sides, or multiply by the reciprocal of the coefficient of x. You can call it, you can say it any one of these ways. So if I were to say I'm multiplying by 1 over 3 on both sides, we can write it this way, and then on the right hand side 6 times 1 over 3, like that. And now 1 over 3 and the 3 in the denominator and 3 in the numerator cancels out, leaving us with x on the left hand side, and on the right hand side 6 is the multiples of 3, so the 3 times 1 is 3, 3 times 2 is 6. Therefore the value of x is equal to 2. We got the value of x, and we'll call this one as step 2. And in step 3 we will go back and then check our work to see whether the value what we have arrived is correct or not correct, or if it is not correct, we'll go back and then trace our steps to see where we have committed the mistake. We'll rectify the mistake, come back, and then make sure that the check performs correctly. So in step number 3, we're going to take the given equation 3x is equal to 6, and we're going to substitute the value of x as 2 now. 3 times 2 is equal to 6. The value what we have on the left hand side, if we were to multiply these two numbers out, 3 times 2 is 6, and the value what we have on the right hand side is 6. Therefore, as long as the value on the left hand side is exactly equal to the value on the right hand side, the check process is telling us that the value of x what we have arrived at is exactly correct. That's the way we want to use the multiplication property to solve these linear equations. Let's see if we can solve another simple example. Let's take another example. This time, let's say we want to solve 3a divided by 4 is equal to negative 9. We want to solve for a. So we'll write it down in these different steps. So we want to isolate the a term and we want to get rid of this 3 over 4. So in here we know that if we have a number, we said if we have a number and if we wait to we want to identify what is the reciprocal of 3 over 4. Reciprocal of 3 over 4 is going to be 1 over 3 over 4. We can also write this as equal to 4 over 3, isn't it? The denominator comes to the numerator, the denominator of the denominator fractions comes to the numerator, and the denominator remains the same. So the reciprocal of 3 over 4 is 4 over 3. And one of the properties of reciprocals is telling us that if we take a number and multiply by its reciprocal, the value should always equal to 1, and therefore that satisfies that. So therefore we're going to multiply by the reciprocal of 3 over 4, which is 4 over 3. We're going to multiply by 4 over 3. I'm going to put a circle around it, times 3a over 4 is equal to negative 9 times 4 over 3. Whenever we introduce a number, we want to introduce it to both sides of the equation. We don't want to change anything. We want to write it as is on both sides. And once we have it in this manner, 4 over 3, 4 in the numerator, 4 in the denominator, 3 in the numerator, 3 in the denominator cancels out, leaving us with a on the left hand side is equal to, and if you look on the right hand side, 9 is a multiples of 3, 3 times 1 is 3, 3 times 3 is 9, and what we have on the right hand side is negative 12. We've arrived at the value of a. We'll call this one as step 2. In step 3, we're going to go and then check our work. Step number 3. In here, the given equation is 3a over 4 is equal to negative 9. We have the value of a as equal to negative 12. We'll substitute that in here. 3 times negative 12 divided by 4 is equal to negative 9. We want to see, when we simplify the left hand side, whether we arrive at negative 9 or something else. So the value what we have in the denominator is 4, and we have a 12 in the numerator. 12 is a multiples of 4. 4 times 1 is 4, 4 times 3 is 12. So 3 times negative 3 is negative 9. That is exactly equal to the value what we have on the right hand side. So the left hand side value is exactly equal to the right hand side value, and therefore the value of a equals to negative 12 is exactly correct. And that's the way we want to use this multiplication property to be able to solve these linear equations. In my next presentation, we shall look at some more examples using the multiplication property to solve linear equations.